Welcome to Lesson 10, Types of Chemical Reactions. Our lesson objectives: determine the type of chemical reaction, complete single replacement reactions, and complete double replacement reactions. So these are some of the types of chemical reactions we're going to encounter this year, and it's going to be your job to be able to identify them. So here are some general formulas for these types of reactions. The synthesis reaction. Synthesis means to make or combine. So we're combining or making one product. Decomposition is the opposite of that. Decomposition means to decompose or break down. So we're breaking down one compound on our reactant side into many products. Combustion is burning. So we are taking a fuel source, and in the presence of oxygen, we're going to burn that and form CO2 and water. Single replacement, we have one substance replacing another in a compound. And in a double replacement, we have one substance in one compound switching spots with the other. So let's see these in more detail. So how do we recognize that we have a synthesis reaction? So as I said, synthesis means to make or combine. So we're combining two reactants to form one product. So when we see the formation of one product, we know it's a synthesis reaction. Decomposition, the exact opposite. So we're going to see one reactant being broken apart into multiple products. Combustion reactions, they're going to have a very similar look. They're all located on, or at least some of them are located on table I, the top 6. And you'll see they all have some sort of carbon-based fuel source, oxygen, and then the products are going to be CO2 and water. The single replacement reactions, we can look for a single element on either side of the reaction. And then you're going to look to see, is that single element replacing another element in the compound. And so if you look here, aluminum is going to actually replace copper. It's going to push out copper. Copper is by itself now as a product. And then aluminum is going to bond with chlorine to form a new compound, aluminum chloride. A double replacement, we have two substances switching places. So we can recognize this and also differentiate this from our single replacement reactions in the fact that we have two compounds on either side, where in the single replacement we had a single element on each side. And so let's see what happens. Our barium is going to switch spots with sodium, so it's going to push out sodium, and then sodium is going to go where the barium was. That's why it's called not a single, but a double replacement. So barium hooks up with sulfate to make barium sulfate, and then the sodium is going to hook up with the chlorine to form sodium chloride. Let's check your understanding. Can you identify the types of chemical reactions? The second thing you have to be able to do is complete both single and double replacement reactions. So let's first look at these single replacement reactions. When we have the beginnings of a single replacement reaction and they ask you to complete that, you have to first see, does the reaction even take place? So we're going to go in a reference table to table J. If this single element is more reactive, meaning is it higher up than the first element in the compound, then it is going to replace it. So we find magnesium and we find H. So Mg is here, H is way down here, so Mg is much higher, so it's more active or reactive, and so Mg is going to replace H. H gets pushed out. I wrote H2 because H is a diatomic element. And now Mg is going to combine with Cl. Now remember, whenever we make a new compound, we always have to put our charges and make sure that it equals 0. So Mg is going to be +2, Cl is a -1. So if I have two positive charges and one negative charge, I'm going to need two of these to balance that out to get to 0. So my formula is then going to be Mg and then 2 Cl's. So MgCl2. Let's see another example. So we have Li, and the first element here is Al. So locate both of those on table J. Li is at the top, aluminum is down here, so since Li is higher up, this reaction will take place. This is more reactive, and so Li is going to push out aluminum. So we're going to get aluminum by itself, and now we're going to combine Li with NO3 to form a new compound. So we look up the charges. Li is +1, NO3 is -1. So +1 - 1, that equals 0. So our formula is going to be one of these and one of these. So it's LiNO3. So let's check your understanding. Can you complete a single replacement reaction? Now lastly, let's look at completing double replacement reactions. So in a double replacement reaction, we're going to take the first element of each compound and we're going to switch spots. So silver is going to go here and potassium is going to go here. So when silver goes over here, it's going to hook up with PO4 and form a compound. So Ag is a +1. We look up PO4 on table E, that's a -3. And now K, our potassium, is going to go over here and combine with NO3. So potassium is a +1 and NO3 on table E is a -1. And now let's form our two new compounds. Remember, they must equal 0. So if we have +1 for silver and -3 for the phosphate, that means we're going to need 3 positive charges to balance out those 3 negative. So I'll need 3 silvers. And over here, this is +1, this is -1, so that already equals 0. So I only need 1 K and 1 NO3. And then I'm going to rewrite my new compounds. So it's Ag3PO4, and then KNO3 is a 1-to-1 ratio here. And let's see one more example. So to complete this double replacement reaction, remember the first thing you have to do is this Fe is going to come here and replace H, and H is going to come here. So when Fe comes over and pushes out hydrogen, it's going to combine with chlorine. So let's put the charges. We have iron is +2 from this compound, and Cl is -1 from this compound. And then when H comes over to combine with S, H is a +1, and then S is a -2. And now we're going to set both of these equal to 0 to figure out how many we need of each of our ions. So we have a +2 and a -1, so we're going to need 2 Cl's here, and then +1 and -2, we're going to need 2 H's here. So now we can set them both equal to 0, so I know that I need 1 Fe and 2 Cl's, and then 2 H's and 1 S. And so we write our chemical formulas as FeCl2 and then H2S. Let's check your understanding. Can you complete double replacement reactions? At this point, you should be able to determine the type of chemical reaction, complete single replacement reactions, and complete double replacement reactions.